Okay, this is notes number 7, dilations. Go ahead and pause the video and write down the focus learning target. So today I'll be able to dilate an image and identify the scale factor. So first, let's go ahead and define what a dilation is. It is a type of transformation that stretches or shrinks an image. So it makes an image larger or smaller. And then to find the scale factor, we actually use the letter K, like how we use M for slope, we use K for scale factor. To find the scale factor, you divide the new image by the pre-image. So the new image always goes on top, the pre-image always goes on the bottom. I'll explain more what that means later. If the scale factor is larger than 1, then that means the image is an enlargement. An enlargement, or it stretches or gets bigger. If the scale factor is between 0 and 1, that means that the image is a reduction. So it gets smaller or it's getting compressed. And then if the scale factor is just 1, that means the image is congruent, they did not shrink or stretch. So go ahead and pause the video, write down all of those definitions. Now let's take a look at our very first example. So you know it is a type of dilation whenever you have multiplication here. So if there's ever multiplication in your coordinate notation like this, when you multiply by 2 or multiply by 1/2, you know it's a type of dilation. So let's write that off to the side. Multiplication means type of dilation. If you look here, we're going to multiply our x's by 2, and then we're going to multiply our y's by 1/2, which also means the same thing as dividing by 2. So if I take a look at my first example, I'm going to go ahead and graph my pre-image. So A is at 0, 2. B is at 2, 6. And C is at -3, -4. So we have this scaling triangle here. We're going to go ahead and apply the scale factor. So that means we're going to multiply the x by 2. Call this A prime. So 0 times 2 is still 0. I'm going to do all my x's first. 2 times 2 is 4. For my C prime, -3 times 2 is -6. Now, we're multiplying the x by 2, but for the y's, we're going to divide by 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. -4 divided by 2 is -2. So be careful. Sometimes the x and the y's will be different. We're going to go ahead and graph this. 0, 1 is A prime. 4, 3 is B prime. -6, -2 is C prime. There is our new image there. When you are describing the transformation, we're going to go ahead and take a look at the scale factor. Now, because for the first one, our scale factor is 2, that means for x, there is an enlargement or it stretches. Now, because it's our x, remember our x is our horizontal. So we're going to say a horizontal stretch by 2, because that is our x value. We're going to talk about our vertical. Now, for our scale factor here, our scale factor is 1/2 for the y. So if it's between 0 and 1, like here, it's 1/2. That means we have a compression. So we have a vertical compression by 1/2. And that's it. We're going to go ahead and turn it over to the next page. Is a dilation a type of rigid motion? So there's that keyword rigid motion that we've been seeing. Rigid motion means that the image is the same size and the same shape. Remember, if you dilate an image, that means you're making the image smaller or bigger. So because you're making the image a different size, it is not a type of rigid motion. So no, dilations are not rigid because the image is not the same size. Right? It has to be the same size for it to be a rigid motion. Like reflections, rotations, translations, all of those guys keep the image the exact same size. So those are all rigid motions. Dilations are not rigid motions because the image does not stay the same size. Okay, so let's take a look at our second example. We have a type of quadrilateral here, and we're going to dilate UVWX 1/2 about the origin. So K equals 1/2. Because this guy is less than 1, that means we have a compression. I'm going to go ahead and first find the coordinates of each one. So we'll start with U. U is 1, 2, 3, 4, 4 comma -1. V is 2 comma 1, 2, 3, 4. W is -3, 1. X is 0 comma -3. We are going to go ahead and multiply by 1/2. We're going to multiply by 1/2 to both of X and Y, so it looks like this. So X comma Y is now 1/2 X, 1/2 Y. So if I just tells you one number, that means you're going to do it to both of them. So it's a little bit different from the very first example. So if I go ahead and multiply by 1/2, U prime, I'm going to divide this guy by 2. 4 divided by 2 is 2, -1/2. You could also put -0.5. For V prime, 2 divided by 2 is 1, 4 divided by 2 is 2. W prime, -3 divided by 2, you can put -1.5, or you can put -3/2. It's the same thing. Comma 1 divided by 2, that's 1/2, or you can put 0.5. X prime, 0 divided by 2 is 0. -3 divided by 2 is -1.5. Or if you want, you can do -3/2. Doesn't matter if you want to use decimals or fractions. We're going to go ahead and graph this new image. 2 comma -1/2 is down here, which is U prime. V prime is 1 comma 2. W prime is -1.5 comma 0.5. So we're going in between because it's halves. And then 0 comma -1.5 is our X prime. We're going to go ahead and combine all 4 of these, and you can see that the image is the same shape, right? It's still that quadrilateral, but now it's just a different size. So that's why these two are not rigid motions. Last example for today. This time I gave you both of the figures. I want you to find the scale factor. So remember, the pre-image is the GHI. G is -1, -1. H is 2 comma 1. I is 1 comma -1. So this is my original triangle. And you can already see that my triangle gets bigger based off of G prime, H prime, and I prime. So knowing this, I know that my scale factor should be greater than 1, and this is going to be a stretch. G prime is 1 to negative 2.5, it looks like, comma, negative 2.5. H is 1, 2, 3, 4, 5, comma, 2.5. And then I looks like it's halfway through, so 2.5, comma, negative 2.5. And now we're wondering, how did I get from my pre-image to my image? So if you can see here, this one shows you pretty well. Negative 1 times something equals 2.5. Negative 1 times something equals 2.5. Remember, dilations are always multiplication. So you can see here that my scale factor is 2.5. Again, if you like fractions, you can write 2.5, or you could even write 5/2. Those are all correct answers, but you should double check to make sure that they all work for all of them, right? The scale factor should be the same for all of them.